Okay, in this video we're going to look at the formation of stationary wave on a string. So how does the experimental setup look like? So you have a oscillator. So this is an oscillator, and this oscillator is connected to a signal generator. So what is a signal generator? Signal generator it's able to produce varying electrical signal. Okay, varying electrical signal, that means different frequency and different amplitude. And this is a string connected to a load, right? And let's say the length of the string is L. Okay, so what is the procedure to do this experiment? Yeah, so the signal generator, the frequency of the signal generator is increased slowly from 0 Hz to a value where a single loop is obtained or observed. Okay, so the first observation, you see a loop like that. The length is L, and this will be antinode, this will be node, and this will be node. So whenever you are analyzing a stationary wave, it is always a good practice if you draw a stationary wave like this and label the nodes and antinodes. So these are all the antinodes where you have maximum amplitude or constructive interference. This is the node where you have destructive interference, and this will be half a lambda, and from here to here will be lambda, right? So always see that the node to node or antinode to antinode you have half a lambda. Node to antinode will be quarter lambda. Always label these up. So in this case is node to node, node to node, this will be half a lambda, and the length is L, so lambda is 2L, right? So the fundamental frequency, because this is the first frequency that this particular wave is observed, will be V over lambda, so V over 2L. So we can also use it to determine the speed of the wave on the string. V equals to F naught 2L, right? So all this can be measured, this can be obtained from the signal generator, therefore the speed is can be determined, right? The second observation, so the frequency of the signal generator is further increased until two loops two loops are observed. So when you see two loops like this, okay, the length is the same. So in this case you have node, 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 anti-node, anti-node. So in this case, node to node is half a lambda. So when you have 2 times node to node, that will be lambda. Okay, and lambda equals to L. So the frequency is V over L. But what is in terms of F naught? Right? So what I'm going to do, I'm going to multiply with 2 over 2. This will be equals to 1. So what you'll have is 2V over 2L. Right? And we know that the fundamental frequency is V over 2L. So we substitute into here. What we have is 2F naught. That means is 2 times of the F naught. Okay. The next thing we're going to look at is the standing wave of sound. So we're going to look at stationary wave or standing wave. Stationary wave in pipe. Okay, so there are 2 situations we're going to look at. One is closed pipe. So the pipe will look like this. The other one is open pipe. This is all related to musical instrument, different type of musical instrument that can represent this situation. Example, flute is one of the example of stationary wave in pipe. So let's look at closed pipe. So for closed pipe, let's say now we have like this. The length of the pipe is L. So I take a speaker, and this speaker is connected to a signal generator. And the same thing, what I do is that I increase the frequency of the signal generator from 0 until I can hear a loud sound at the mouth of the loud sound from the mouth of the pipe. Okay, so I look at the frequency of the, find out what is the frequency of the signal generator. So what is happening here, you will have a formation of node, in this case an antinode. So how it's going to look like, it's going to look like something like this. Now if we further analyze the stationary wave, so we know the stationary wave is going to look like this. And this will be node, 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 antinode, antinode, antinode. So the loud noise is produced at the region of antinode. Okay, now if you analyze these, node to antinode is quarter lambda. Okay, from here to here is quarter lambda, which is equals to L. So lambda is for L. Fundamental frequency is V over lambda. Okay, that's because V equals to F lambda, so V over 4L. Right, so if we further increase the frequency, right, we're going to observe the next loud sound over here. This is the first fundamental frequency. This is the next frequency. Okay, I'm going to call this F1. This is the next frequency, F2. Okay, so what is F1 in terms of F0? This is what we're going to find out. So for that we need to draw the diagram. Okay, this will be node, antinode, node, antinode. Okay, let's look at this. We have node, antinode, node, antinode. That means two nodes and two antinodes. So two nodes and two antinodes, right? This is how it's going to look like. So you can refer to this diagram and you can draw. All right, the length is the same. So in this case, how many lambda is this, right? So if you see carefully, this is half a lambda and node to antinode is quarter lambda. So in this case, this will be 3/4 lambda, right? So node, antinode, node, antinode. Okay, this will be 3/4 lambda, which is equals to L. So lambda is 4L/3, right? So F equals to V over lambda. So V over 4L/3, 3V over 4L. So in this case, 3V over 4L, and we compare this value over here is 3 times the fundamental frequency, F1. So you see there is a pattern. Okay, F0 is this, V over 4L, F1 is 3F0, right? So if you further analyze, what do you think? So you no need to use this, diagram to find out what is F2 in terms of F0, right? We can use this particular diagram to find out. Okay, let's see how to do it. So in this case, F2, we need to find out how many lambda is this from here to here. How many lambda? Okay, let's see. This is 1 lambda. Okay, this is 1 lambda from here to here, and this one is quarter lambda. So this will be 5/4 lambda. Okay, so 5/4 lambda equals to L, right? So lambda is 4L/5. F2 is V over lambda, so V over 4L/5, 5V over 4L, 5V over 4L is 5F0. Right, so that means the first one, this is F0, this is 3F0, this will be 5F. So you can predict the next one. F3 will be 7F0. So there is a pattern. Okay, right, let's look at open pipe. Open pipe looks like this. Okay, like what I advised you earlier, draw a stationary wave, right, like this, label the nodes, antinodes, right, and how the sound is going to produce is going to be something like this. This will be antinode and this will be node. This is L. So that means the sound is produced from here to here. So from here to here is half a lambda. So half a lambda equals to L. Lambda is 2L. So fundamental frequency is V over lambda. So V over 2L. Okay. So how about here? What is the sound going to be produced here? Let's draw the diagram. Okay, something like this. So this will be antinode, node, antinode, node, antinode. So how many lambda is this? So we have another half a lambda. So in this case it will be lambda equals to L. So F1 V over lambda, so V over L. So this will be again the same thing like we did for the string. So 2 times, this is 2 over 2, yeah, V over 2L. Okay, so the fundamental frequency is 2 times the fundamental frequency F1. There you go. Okay, that's how it happens for the open pipe. Okay, that's all. Thank you.